Hey guys, welcome to my channel Coding Shinobi, and today we are going to see important questions related to collections in Java. This is by far the most important topic because it will be tested on your DSA knowledge as well with regards to Java. And since collection is a vast topic, we might need a few more videos regarding collections as well. Also, we'll start with the basics of collections and then we'll start with and then we'll see what is the difference between different collections, how they are internally implemented, which data structure is used by Java internally for implementing those data structures or those collections. So I hope you get to learn something new from this video. I hope this video adds value in your interview. So all the best, guys, and let's get started.
Hey guys, so we are going to see about Java collections and the most important interview questions related to collections in Java. We will start with a basic question: what is collection in Java? Collection is nothing but it is a framework provided by Java which provides an architecture for storing and manipulation of collection of objects or data, capable of doing any data operations such as searching, sorting, insertion, manipulation, and delete. And there are two basic root interfaces of collection framework, which is collection interface and map interface. Map has totally different hierarchy, different from collection. Okay. What is the difference between collection and collections in Java? So collection and collections is not similar. Collection is an interface wherein all the other interfaces extends this interface like list, set, queues and all other data structures that you see. And collections is an utility class which is used to perform operations on the collection. Collections allow you to perform operations on the collection, on the implementation of collection, which is provided by the classes like ARList, LinkList, Priority Queue, etc. And both this interface and class is in java.util package. Okay. And to perform operations on this collection classes, static utility methods from collections class can be used. All the methods in the collection classes are static. Since there is no point having state, right? We are just using these methods to sort, to reverse the order and all other stuff. Examples of collections are collections.sort, collections.minimum, which returns the minimum element in the collection, and collections.max returns the maximum element in the collection, present in the collection. Okay. So next is, this is one of the important question, guys. Explain the hierarchy of collection framework in Java. The most important, you can say, or most frequently asked question in interviews. Like I have given interviews of so many companies, and almost 50% of the organizations have asked me this question. And this becomes tricky because you might think collection is the root interface, but we'll see what is the root interface of collection framework in Java. Entire collection framework hierarchy is made of 4 fundamental interfaces, which is collection, list, set, and map. And 2 specific interfaces for sorting called sorted map and sorted set. And you'll see at the top there is iterable interface, which allows which allows user to iterate on every collection that is extending from this interface. The collection extends a iterable class, and then list, queue, and set extends collection class. Then the implementation of lists are ARRAYList, LinkList, Vector, and Stack. Then there is DQ, which is also known as double-ended queue, and the implementation is array queue. And the priority queue is the implementation for queue. For set, hash set, and linked hash set, and for sorted set, it is tree set, which maintains the order in ascending order or descending order. What are the advantages of collection framework? What could be the advantages of collection framework? Firstly, it is like consistent API. All the methods of collection classes are like same like add, remove, set. So whatever collection you are trying to use, be it list, be it set, or be it a queue, if you want to add a remove element or you want to edit the element, the methods remain same. Whatever implementation is there is given by the respective classes or respective implementations of those classes. but the API remains same. It also cuts programming effort. Instead of writing the programs from scratch, you can make use of collection framework, because the data structures used internally by Java are already optimized, right? Improves program speed and quality because optimized implementation of data structures. Program doesn't need to worry about implementing certain data structure in optimal time complexity. Like collection.sort implements dual pivot quicksort internally, modified quicksort with nlog in average time complexity. The worst time complexity still remains L squared, but average time complexity is nlog n. Explain various interfaces in collection framework. As we have already seen, mainly iterable, collection, list, queue, and set are the most important interfaces. But we'll see all these 7 interfaces in detail. First one comes iterable interface, which is the primary or the main interface. Extended by collection, so all classes are implementing this interface. And the primary purpose is, of course, to provide an iterator to iterate all over the elements in the collection classes. The ability to iterate over all the elements in the collection classes, it is because we need to implement this iterable interface, and all the collection classes implements it by default. There is only one abstract method, iterator. Then second comes collection interface, which extends iterable interface, of course, and declares all of the behaviors that collection classes can have, which is add data, remove data, clear data, etc. Collection classes implement the methods with their own set of instructions. Of course, the addition of insertion, the deletion of each classes or each data structure will be different, right? For ARList it is different, for linked list it is different. Those it is provided by the respective implementations of those classes. This makes the collection area to be consistent, right? And it basically provides the basic behaviors to collection classes. Third one is list interface, which extends collection interface and deals with all the list data like ARList, LinkList, Vector, Stack. List contains objects with ordered collections. The insertion order is preserved when you are using a list. So we can create a list of any objects using this interface, like list of objects, new ARList, list of objects, new linked list, list of objects, new vector. Fourth one is queue interface. So queue is basic. It also extends from collection interface. Queue has the basic functionality of first in first out. Like you are building a restaurant application wherein you want to serve the customer as per the first come first serve basis. You can use queue there. Priority queue implements this interface. DQ interface. DQ interface is also known as double-ended queue. It extends queue interface. Elements can be added and removed from both ends. That is the double-ended queue. An array DQ implements this interface. Set interface extends collection interface, and it is used to store unordered group of objects, and also unique elements are stored. Hasset, reset, and linked hasset implements this interface. Only unique elements are allowed in set. No duplicate is allowed in set interfaces. Sorted set interface. It is very similar to set interface, but the order is maintained in sorted set interface. The only difference you'll find is additional methods for maintaining element ordering, and tree set implements this interface. Basically, tree set is stores the data in a sorted manner. Difference between ARList and LinkList in Java. This is also one of the commonly asked questions to test your knowledge how these lists are internally implemented in Java. So we'll see one by one. ARList uses dynamic array to store the elements. We'll see what is dynamic array. And linked list, it internally uses doubly linked list to store the elements. Dynamic array is nothing but a normal array. Whenever the capacity of the array is reached, it will create a new array, copy the elements from the previous one to the new array, and the insertion will start in the new array. That is basically the dynamic array. Adding or removing from middle is very costly. Of course, we need to shift the elements to the right or to the left, right? And the complexity remains omega of n. Adding or removing elements is faster. See, yeah, here also the time complexity is big of n, but no shifting is required. Shifting takes a lot of amount of time because it will take lots of swaps. Better for storing and accessing data. Wherever you want to access data frequently, go for ARList. Wherever you need, wherever you need to add or remove elements, go for linked list. So accessing data takes time, big of n, because you need to travel through every node to go to that particular data. And here, if you know the index, you can directly calculate it from the base address and you can directly access it from the array. Here the memory is contiguous. Since it is the internally array is implemented, the memory is contiguous. That's why it makes the accessing better, right? And it is not contiguous, of course. ARList is resizable array with some initial capacity. As we have seen, internally we use dynamic array and it is nothing but a resizable array. And initial capacity, the default capacity is 10, I guess. And in linked list internally uses doubly linked list and no resizing is required. Whenever a new data comes, only a new node is created and attached to the tail or head of the linked list. Difference between ARList and Vector in Java. So the similarity between ARList and Vector is both internally implements dynamic array, but ARList is not synchronized, but Vector is synchronized. All the methods in the vectors are synchronized. They are thread safe. Increments 50% of the array size when resizing. Whenever the limit is reached, when the element limit is reached, array size limit is reached, it will create a new array with 50% of the original array size, and then it will copy the elements from the previous array, old array, into the new one. And when it comes to vector, it increases 100% of the array size. ArrayList is fast, of course, but because it is not synchronized, right? It is slower because it is synchronized. It is thread safe. The acquiring locks and all other stuff makes it slow. It is not thread safe, but vector is thread safe, of course, because of synchronization. Difference between list and set in Java. List is an ordered sequence wherein insertion order is preserved in list. Set is an unordered sequence. The order is not maintained. Duplicate elements are allowed. You can add as much duplicate elements you want in list, but set only have unique elements. Elements can be randomly accessed based on the position. There are methods provided in the list interface wherein you can just get uh, get a particular element using get method and passing the index into the get method. But for set there is no random access since the sequence itself is unordered, right? Can have several null elements because duplicate elements are allowed. It can have several, but since only unique elements are allowed, it makes sense to have only one null element, which should be unique. Also, like you are given a problem wherein you have given a duplicate elements and interpreter just wants to find out unique elements from the array or list. You can just pass it onto the set or use a set for that, which will have bigger of n time complexity and space complexity. That's not part of our discussion, but that is one of the most commonly asked program. Difference between iterator and list iterator. Iterator has the ability to only traverse in forward direction, and it can traverse both forward as well as backward direction. As the name suggests, it can travel everything like map, sets, and list. But if you look at this name, list iterator, only you can only traverse list. The name itself suggests. It throws concurrent modification exception when tried to add elements while iterating. But at any time, you can add elements to a collection. Cannot be used to obtain indexes, iterator, because you can also traverse on sets and maps, which also stores unordered data, right? So it doesn't make sense to obtain indexes. But in list, of course, it makes sense. So next index and previous index are the methods which are provided to access indexes. So guys, that was all about like the basic questions related to collections.
So guys, thank you so much for watching this video. I hope you got to learn something new from this video. And if you have any topic in your mind, do let me know in the comment section. And if you like the video, please do like, share, and subscribe. Till then, bye bye. See you guys in the next video.